Oh, it works. So MTR stands for mathematical thinking and reasoning. So in addition to like the standards that we teach, we're also supposed to like do these thinking and reasoning skills. There's a poster here that shows it. There's 7 of them. Probably almost none of you can read the poster, so every once in a while I'll just post it. Number 7 is apply math to real world context. So we're going to be doing that today. We're just doing word problems today, tables and graphs. I think I was gonna do like 4, but like last class I only did 2, but it was enough. So we're gonna apply math to real life today. Thank goodness. More and more people are saying, right? Like, why math aren't I talking about anything I can use? Not just for the engineers. All right, who's got their slope formula down? Yeah, will you tell me it? All right, so given any 2 points, you can calculate slope. And slope is the same as like rate of change or rise over run. So we're going to use that in every problem today, slope formula. So keep that in the front of your mind. Before we start today's new topic, we need to check homework. So did we put answers for 15 through 20 on the board in this class? Okay. Let me know if you have questions about those. I need to see those that you did them. And then I also need to see the mini assessment. So that's what you have out. No. Hey, you guys, really quick before you start checking with each other, I wanted to talk about this number 2 in the mini assessment. A lot of questions on this. So I want to give you a chance to get it right now. It says to compare F and G, and it just gives you a table. So our X's are the same. You can kind of ignore it. This F is like a Y value. This G is how the Y values have changed. So I want you to try to figure out how are these Y values changing and then describe that using the transformation vocabulary. Okay, so if you left number 2 blank, talk about it in your group and try it right now. And then I'll also go over 3 and 4. Those I know those should have been questionable. All right, group, good job. Mini assessment answers. All right. So I will talk about number 4, 3 and 4 actually. number 3. All right, so when you're looking at all of these symbols, so this negative in front, we got g of x is, g of x equals the same, g of x is the negative entire function. So I'm going to put a negative sign there. And then 2 units to the left from there. So plus 2 means move 2 units to the left. So if you wrote the equation, that's what it should look like. And here it is at 5 and it's reflected down. Number 4, c of x. Would be negative. And then if you're going 2 units to the left, you would write it like this. This is full credit. So it's negative, and then 2 units to the left, you're supposed to put in parentheses with x. So I saw people do it without the parentheses, and that's really great. Just if you're doing the negative and you're followed by a translation, put the especially horizontal, like put that h right in those parentheses. So what they've done here is distributed it in. So these are the same thing, as long as the parentheses are there. Did anybody write plus 2 in their equation? Okay, good. So either way. Any questions not on 2, 3, or 4? So yeah, 2 is just up 4 because the y's are changing by 4 every time. Alright, if there's no questions, we'll start on some new examples right now. It's going to be chapter 1.3, so go back to your notebook, chapter 1.3. But in your notebook, so it's good. So, you don't have to write the whole heading, but please put in your notes that this is 1.3 so you know where in the book to find it. We're modeling with linear functions, so everybody write y equals mx plus b. That's what we're doing all day today, y equals mx plus b. I supposed to be? I want to make a connection for a moment as to why, what that has to do with transformations. So what does M represent? A slope. So y equals x is the parent function with a slope of 1, and what does b represent? Y-intercept. So this could be written this way. This is the same thing, right? A is a stretch or compression, and K is a vertical translation. So these things are equivalent. It just isn't quite tied together like perfectly in curriculum. We talk about transformations as A's and K's, but we teach you MX plus B before that, and we call MM and BB. And then maybe we need to go to algebra 1 and start calling it A and K, because they're the same thing. Okay? You can put an H in there, but when you rewrite it, it looks the same, right? All right, so this is work with a partner. So you're supposed to talk about this. This table shows a company purchased a demolition robot for $87,000. Gosh, that sounds like a lot of money for a robot. Crushing stuff up. Like I'm picturing like Wally. The spreadsheet shows how the robot depreciates over an 8-year period. Determine what kind of function it is. Explain how you can write a linear function of the value v of the robot over a number of years. Sketch a graph. The graph I want you to do, so you're going to put time in years down here. So you're going to go like maybe up to 10. And then we need to hit $90,000 here. So you can go by tens here, but like do 90,000, 80,000. Okay. So sketch a graph and explain why it's called straight line depreciation. So your main goal is to write an equation y equals mx plus b to model this table, and then to understand what it means for the robot. And I'm going to say last and let you guys work on it. Can you figure something out? Oh, no, it's okay. I did it for you.
What are the numbers on the side here?
Yeah. So it will get easier than what you're experiencing right now. It's not every week. I don't make computer. You don't have access? Good. But you can't see like my computer. I'll look at it. I'm sure there's some. Yeah. You know, maybe you should talk to Gary and see if they really have a really good idea.
No, we just do them. What's a linear function? So the y-intercept would be, and then I did 90. I just did the ones y-axis by 10, and then the set.
Okay, no problem. Okay.
It's technically by thousands, but I just didn't want to write that out.
I'd love to see like a calculator out. So Monday I'm actually gonna check for calculators for accountability points. I'm taking all your points, 5 points for the whole week if you don't have a calculator on Monday. It doesn't matter what calculator. I recommended a calculator, but any calculator Monday will give you your credit. Any calculator besides a phone. The problem with relying on your phone in class is on a quiz day, you can't have your phone out. And then you're like, well, shoot. And then students they'll borrow a calculator like on quiz day, and then they'll be like, Miss Bowen, how do I use this? And it's like in the middle of a test. So use the same calculator every day in class, and you get good at it. Not your phone. So clearly it represents a linear function. They kind of gave it away. So determine what type of function is represented in data. It forms a straight line. The linear function. Explain how to write a linear function. So we're doing y equals mx plus b. So what's our first move? I'm calling somebody. Jaden, what's our first move to write a linear function for our data?
Is it before or after we already write?
Like I don't have it. Like yeah, no. Did you get a number for M or B yet?
No, I have it wrapped. Do I pick a random point on it, or do I?
Yo, let's just pick some random points to find our slope. Pick a random point. You did it, Jaden. Okay. So we can do this is our first point and this is our second point for our slope. So I have 87,000 and I have 79,750 and I'm going to do slope formula. Did anybody find the slope yet? Sean, you found it? No? Natalie, you found it?
Was it negative 7,250?
There it is. Negative 7,250. And what's our B value? 87,000. It's the y-intercept. All right, here's our y-intercept at 87,000. Looking at a table, a value of 0 is always a y-intercept. So here's our function. I'm going to fancy it up a little bit. I'm going to say v of t. So the value over time is negative 7,250 times the number of years plus 87,000. And that's a function based on a given table, a linear function. So why is this depreciation called straight line depreciation? Does anybody know what depreciation means? Yes, it's going down. This robot is going down each year. Any idea why we might document depreciation? So this is a huge part of accounting. So corporations will hire accountants to document how their assets depreciate. So for one, if I want to sell this robot in 3 years, I need to figure out the listing product, the listing price. I can sell it for 65,000. I can say, yeah, it was new. It was worth 87,000. I used it for 3 years, and now I'm selling it for this. And the government actually provides percentages in like methods for depreciating equipment. So I have something to show you. Investopedia is not like the best source, but it actually is really clear for helping you understand finance. So this is ways that corporations save money. The biggest way corporations save money is reducing the amount of taxes that they pay the government. So it's kind of a disadvantage for us because we can't all hire accountants, and corporations have people who work full-time trying to figure out how to reduce the amount of taxes that they pay the government. But some people, how many of your parents have an accountant? Anybody? Yeah, if your parents own a business, they probably have an accountant, or maybe your parents are an accountant, right? So corporations have 4 ways to reduce or eliminate the taxes they pay. The first one is accelerated depreciation. And it actually says here that accelerated depreciation is the most rewarding of all of these tax breaks. So what happened is that like corporations would get money, like oh, I made $400,000 this year, and then the government every year says you have to pay taxes on what your business is worth. So I have to take my $400,000 and I have to pay the government like a tax rate. So what companies did is that right before tax season, they would buy a bunch of stuff. And they'll say, I don't have that much money. I don't have to pay these taxes. So the government says, well, you have to claim that stuff that you bought. So if I say I have no money, but I have 4 Ferraris sitting in my company parking lot, I can't say I have no money. The government says you have to claim those Ferraris and pay taxes on them because they're a part of your assets. Okay? So corporations can't do that. They can't just buy something before taxes and say they don't have that money. So when you do buy something like a really expensive robot, it's sitting in your factory, it's worth $87,000. The next year, though, is it still worth that much? It's not. You used it for an entire year. So you document that. And when you go to pay taxes, you say, well, my asset is actually only worth $70,000 now. And 5 years down the road, I don't have to pay the full price of taxes. I pay much less on it. So corporations have people. It's their entire job to look at how much money the company started with in their equipment and document the depreciation of the equipment so that those corporations pay less taxes. save taxes is by offshoring profits. Anybody know what that is? Yeah. Yes, you can. So people start to say like, this isn't constitutional. Like, what if the government just decides they want to take half my money this year? So the government says, okay, well, you can put some money in another country, and when it's there, the taxes are different. You don't have to pay taxes the same way. So they will store money offshore. They still have to document it, but the government has less access to it. It's more yours. Stock options is one way, and then maximizing tax credits. So like I said, out of all those ways, companies they'll spend a good amount of money making sure that their equipment is depreciating well. And like now, so right now prices are really high on everything. So this robot right now might cost $200,000. And in 5 years, if prices like go back to normal, like inflation goes down, the depreciation rate will be a little bit different. And that's like a translation, right? So that accountant will claim, well, inflation's different now. My equipment's only worth instead of going down 7,000, well, this year it went down 20,000 because inflation went back to normal. Okay, so that's people's entire jobs. Apparently, tech companies are particularly agile at stashing cash offshore. That's interesting. Probably because they're like really good at like wiring things, right? Keeping things secret. I just thought of that. Not all offshore money is secret. Okay, so that's straight line depreciation. This is what's important for today's lesson. You have to interpret the slope and intercepts. This means complete sentence answers. You're going to do this 4 times on your assignment today. If when I walk around and grade it tomorrow, if I don't have complete sentence answers, I'm not giving you credit. So can somebody explain what the slope means with this robot? I'll get you started. The slope of negative 7250 shows. Yeah.
The value decreases $7,250 per year of ownership.
Love it. The value decreases. Write it down, you guys. $7,250 each year of ownership. Well, really well said. They'll be like, actually, we use that overtime. I'm gonna take less off of it. We never took it off. We got $14,000. The y-intercept of $87,000 shows the starting value of the robot. The x-intercept. We don't know yet. We haven't calculated it. What's the x-intercept? So if you continue the data, you can continue the table or continue your graph. What's the x-intercept? Where does our data hit the x-axis? Standard. Twelve. 12. How'd you figure that out? Okay, good. I personally would have just like kept subtracting, right? Like, oh, this minus this minus this. So yeah, it's gonna go through right at 12. This is an x-intercept. So the x-intercept of 12 shows anybody else in the room understand what this 12 shows in our problem? Yes, in 12 years, this robot is worthless. The exponential shows when the robot is worth $0. Okay? So if you've had the robot for 14 years and you can sell it for $2,000, you get to pocket that $2,000. The government doesn't see it. I mean, you should document everything. I'm not saying not document, but it's not taxable anymore. Like that $2,000 is yours. Like you got to sell it even after it had depreciated completely. Now, if the robot breaks before that 12-year period, you're pretty upset because you were paying taxes all along, and then I think you just have to like prove it's broken, but I don't know. Okay, so you're interpreting 4 graphs for your assignment, and I need full sentences like that. Let's do one more. Okay. All right, this is a real asteroid. 2019 GC6 is about as large as a house. NASA and several international organizations are constantly scanning our skies for threats from space rocks. This shows how fast the asteroid moves. In 2019, in April, it was 136,000 miles from hitting Earth. Did anybody see that movie that came out about the asteroid? I know. It was rated R, so I can't recommend it, but it talks about this, like if an asteroid really hit. All right, you guys, write an equation. I'll give you a hint. We got a point at 0, 0, and we got a point at 621. So we need a y equals mx plus b equation. And then I want you to interpret the slope with a complete sentence answer. You don't have to redraw the graph. Nope, you don't have to do that. The graph is provided on your assignments today. The graph is provided. You just have to come up with the equation and then explain it. No, I'm gonna go all the way up to that 621. If they provide one, then use the one they provide. But they should. And if they don't, we have to provide it.
That's kind of easy.
It actually isn't a bug, but it gives the answer. Can reduce your fraction. 7 over 2. They both divide by 3, right? So I'm at y equals 7 over 2 x plus 0. Since the y-intercept b is 0, I don't like to put plus 0, so I'm just going to put y equals 7 over 2x or distance as a function of time is 7/2t. Or 3.5x. I don't like decimals with word problems. Sometimes they are best just to talk about it. So can anybody talk about 7/2 or 3.5 with regards to this asteroid? Okay, Xander.
It travels 7 miles every 2 seconds or 3.5 miles.
Ready, complete sentence. The slope shows. The asteroid moves 3.5 miles per second, and I can't even believe that. I'm having a hard time. I'm really uncomfortable with anything moving that far that fast. Like, that just shows me, like, how much I don't know about what outer space is like. I want to talk to an astronaut. Like, this is serious. I guess everything's really far away from you, so you can, like, you know, it's moving really fast, it's so far away, it doesn't look so fast. Like, something in front of you moving that fast, you probably wouldn't even see it. It's probably invisible. Like, time travel. How long does it take okay, so the asteroid was 136 miles from us. How long would it take moving this fast? How long would it take for it to get to Earth? How long would it take to go 136,000 miles? I got my sentence ready. Okay, man, how am I gonna figure this out? Well, I know distance equals rate times time, and you don't have to do that. You guys can come up with this totally logically. You don't have to use the formula. But I can. I'm gonna put 13600 equals 3.5 times t, and then I'm just gonna divide both sides by 3.5. I get that it's gonna take 38,000 seconds for it to hit Earth. So when it was at its closest point, if it was just a little angled differently, it would have hit us in 38,000 seconds. But I don't want to answer in seconds, so I'm gonna divide by 60. It tells me it's 640 minutes. Divide again, and it tells me 10.8 hours. So had that asteroid been off course just a little bit from its closest point, it would have taken 10 hours to hit us. If the directions don't clearly say answer in hours, then I would have to take it. Okay. But if they do, pay attention to that. All right, you guys, go ahead and open your packets to page 26 so you can take a look at 1, 4, 6, and 7, your assignment. The graphs are given for you. You can take a picture of them right now if you like. Page 26.